Okay, we are going to start the very wrong button, last section of this fall 2020 semester. Okay, don't know how zoomed I am, but let's do it. Okay, so the last video, what we did was 6.5, which was determinants and Kramer's rule. I believe we did 2 by 2s and 3 by 3 matrices. And we actually also did an example in the third part of 6.5. I'm looking at a 3 by 4 and being able to actually solve that one as well for the variables. So we're going to kind of go backwards in our book. What we're going to do now is 6.1. I actually don't have things pre-written, so I'm hoping it doesn't take too long. Let's see. So this is 6.1, which is going to, so they call it matrix solutions. More specifically, the way we're going to solve a matrix is going to be with the Gauss-Jordan elimination method. This is that section I told y'all that I love. Elimination method. Okay, so I'm going to go ahead and just kind of explain a couple of things, okay? So I mentioned in the last video, if you have a matrix, right, just a single matrix, you call it a matrix. If you have multiple, you would call it matrices, right? If you're referring to more than one matrix, more specifically, matrices, this would be, like I said, the plural of the word matrix. What they are is an array of numbers. We're going to have something that's called an augmented matrix. And more simply put, just if it tells you to transform or change a given matrix into its augmented form, the only thing you do is you just write the coefficients only, okay? So coefficients, it's the constants. So it's going to be both of those, okay? The coefficients and the constants only. It's the only thing you're going to write, okay? Your constants, because these would be written in, say, an equation form. These would be where I would pull, because I pushed that button. I don't know what that button does still. How much I want to paint my screen just like goes away. Ay, ay, ay. I don't get it. Let me do this. Okay, let me go out of it. Let me come back. Okay, so it's going to be written as an equation. Okay, well, let me get any smaller. It's going to be written in a form that you are familiar with. Goodness gracious. Let's just actually completely close that, go home, and go back. I've pushed this button before. I don't know why it's all wonky now. Okay. If this is written in, say, this form, my coefficients would be 1, 1, -1, and then my constant would just be 3. And you'll notice that, because we'll have more than one equation, right? I have it written in this way because we do have our brackets on the sides. There's just going to be a line that separates coefficients from constants. This is what our equal sign is, basically. So it's just kind of a little side note there. That's what I mean by coefficients and constants, okay? So an augmented matrix, you're just going to pull the numbers from it, correct? Our goal whenever solving these problems is to get the matrix into a row reduced echelon form. So that's row reduced. I don't have echelon. I don't have the word in front of me. Echelon form. There could be a typo with echelon, y'all. And a row reduced echelon form is in this format. We have a 1, 0, 0. Go ahead and do your line that separates it. This would actually be the answer to my x value. And then we have 0, 1, 0. We have 0, 0, 1. And if you notice here, my ones are in a diagonal. Okay. This would be my X row. That is my, column. That is my Y column. That is my Z column. Because I have a 1 here and all zeros here, this ends up being my answer, whatever I have there. And then right here in the Y column, I have a 1, all zeros here. Whatever I have here is my Y. And then here in the Z column, I have my 1. I have all zeros here. So whatever numerical value is here, that ends up being my Z. Okay, it has to be in this form right here in order to have solved for those variables. Okay, let me go ahead real quickly and explain a few things. You're going to actually solve these matrices using Gauss-Jordan elimination method by actually applying row operations. So I'm trying to make sure I don't push that button. Let's do some row operations examples. Each row operation for each unique matrix, the row operation itself is unique. Okay, it'll never be it might even seem like you're doing the same thing over and over again, but it'll ever be the exact same thing. You'll notice there's always going to be variations in it. A few different operations. Let me go ahead and kind of identify these real quick for you. Okay, y'all. So we have rows and we have columns, right? So this right here is row 1. This is row 2. This is row 3. Right here I have column 1, column 2, column 3. Column 4. Linear algebra. I'm trying to think of what else. Linear algebra, computer science. A lot of the upper level maths that you could be moving towards, you could really dive in a lot deeper with these matrices than we do in our class. I believe we barely scratched the surface here. And it really is quite interesting. I mean, of course, I'm going to say that, but I really do love them. Okay, so those are my rows and those are my columns. I'm trying to think if there's anything else I can add before I say these. Okay, I feel decent about that. Few row operations here. If you see, it's like R sub 1, right? Row 1, and you see a double arrow, and then it says row 2, what you're doing here is you're interchanging
Sorry, I couldn't quite hear you.
very,
Could you please repeat what you said?
very random, Siri. No, I wasn't talking to you. You're interchanging rows, okay? And it doesn't always have to be row 1 changing with row 2. You could do row 1 and row 3. You could do row 2 and row 3. You could do any combination of the rows, okay? I'm just wanting to show you that that operation symbol means change, means switch, okay? If we have something that looks like K times row 1, right? I'm not going to say R sub 1 anymore. It's row 1. If I have something that says K times R1, and then we have an arrow. We got row 1 again. Okay, so this is saying that what we're doing is we're I can't even spell, applying a constant to, I'm just going to say to row, because it can be row 1, row 2, row 3, whatever you want, okay? But if you do have like a number and then it's touching R1 or R2 or R3, that's a constant multiplying that whole entire row, okay? Not just, one value, but the whole row. And then if we have, I feel like I pushed the button, y'all. If we have something like row 1 plus row 2, quite literally, we're adding. Let's go ahead and say combining. You never want to say adding and then you see negative signs and it looks like subtraction. We're going to say we're going to be, we're combining rows. Okay. Let me go and add this one right here. Say we have a row and we're dividing it by a constant. Oh, of course I did that. Let me actually write this a little bit more technical. Say we have row 1 plus row 2, and that'll give us our new row 2, right? Here was a constant times row 1 gave us a new row 1. If I do row 1 divided by a constant, I'm going to end up getting a new row 1, and this would be dividing row by a constant. Okay, so I think that's good right now as far as like the different row operations that we can use. I'm going to go ahead and just kind of put an example up here. We're actually not going to solve it. We're just going to apply a couple of row operations. I would like to explain, is that what that is? 3, 18, 12? Yeah, okay. I would like to explain something as far as like our goal, like the reason why we would even apply these row operations. Of course, I said earlier that our goal is to get it in row reduced echelon form using row operations. Our steps, y'all, what our goal is to make row 1, column 1 equal 1. If it already is 1, you don't have to do that step. Okay, so make row 1, column 1, 1, right, equal 1. Then we're going to use row 1 to, I put on here to make rest, but it kind of seems weird. Then use row 1, column 1 to change row 2, column 1 and row 3, column 1 into zeros. And then after you do that, what you would do, it's going to be very redundant, y'all. Our next goal, right, would be to make our row 2, column 2. Y'all, have you noticed patterns, especially in these problems? Go ahead and just start like remembering them and recognizing them and using them, okay? Row 1, column 1, row 2, column 2, row 3, column 3. It wasn't as bad as it could have been, huh? Okay. We're wanting those to be 1s, right? How do I know I want those to be 1s? I know I want those to be 1s because my goal is to get it into this form. Row 1, column 1 is 1. Row 2, column 2 is 1. Row 3, column 3 is 1, right? And that's what I'm saying. Turn row 1, column 1 into 1, and then turn the rest of the column into 0, right? And then turn row 2, column 2 into 1, and then turn the rest of the column into 0. Those are my goals. Those are my steps, okay? Use row 1, column 1 to change. Yeah, because I turn this into 1, and then I make the rest of the column. Those are both column 1s into 0s. So then after we do this, we're going to use our row 2, column 2 to change. Okay, so this would actually be row 1, column 2, and row 3, column 2 into 0s. Write everything down in your notes, y'all, but hash marks mean like I'm repeating, okay? Hash marks, you know what I mean, like quotes. I'm using the exact same words. So then use row 3, column 3 to change. So I've got row 1, column 3, and row 2, column 3 into 0s. Okay, so I know there's a whole bunch of like what is going on here, but like I promise it'll make a lot more sense whenever we do an example. Like I said, this one we're not going to solve, but I'm going to show you a couple of row operations, and they're not just any row operations. They should be specific, especially if you're solving the matrices. You don't want to just do anything anywhere, okay? So let's go ahead and let's look at this matrix, which is 3, 18, negative 12. And we have our line, right? Have 21. And then for row 2, what I have is 1, 2, negative 3, 5. For row 3, I have negative 2, negative 3, 4, negative 6. Okay? So my steps were to make row 1, column 1 equal 1. This is row 1. This is column 1. Do you see where that intersection is? That's row 1, column 1. Okay, that value in row 1, column 1 is 3. Mathematically, how could I make 3 equal 1? Well, if you look up at your row operations, I know that I can actually divide a row by a constant, right? So wouldn't I want to multiply row 1 by 1/3? Or a lot of people would prefer this. What we would do is divide by 3, right? Row 1 divided by 3. I could look at my other rows and I could see if anything in this column already has a 1. And I noticed that because something does, I don't need to do those previous row operations. Sorry, I thought I heard something outside. Kind of creepy. What I can do instead, y'all, is I can interchange these rows, right? There's already a 1 here in this column 2. It happens to be row 2, column 2, and I need it to be row 1, column 2. So why don't I go ahead and just interchange my row 1 with my row 2. Now let me go ahead and write this. I'm actually switching, so now I have 1, 2, negative 3, 5. Now I have 3, 18, negative 12, 21. And I have a negative 2, -3, 4, and a -6. Okay, so following my steps, make row 1, column 1, A1. Did it, right? Usually what you might see me do is I'll put a square over it because I'm knowing that I need that to be a 1. Once I move to this area and my row 1, column 1 is a 1, I don't keep the square on it, okay? Now, what it told me to do, I need to use this 1 to turn row 2, column 1, and row 3, column 1 into zeros. So what you'll see me do is I'll circle these. Those need to be zeros. Let me look at them mathematically and try to figure out how can I turn 3 into a 0. Well, if I divide by 3, that turns it into 1, so it doesn't work, right? I have to do row operations. I have to actually use a row and mathematically do something with another row, right? I couldn't just look at this and think, oh, I'm just going to subtract 3 from everything, right? No, I need to actually work within the matrices. Okay, I'm not looking at them as individual equations. I'm looking at how can I manipulate what I have to get what I want. Okay, so looking at this, I know I need to make that 3 become a 0. That's a positive 3. I know that if I add a -3 to a positive 3, those are additive inverses, and what happens is they cancel. Well, how can I even create or use -3? Like, how could that happen? Right here, using the fact that I turned that into a 1, that's my goal. Use that to multiply to whatever you have to multiply it to get whatever you need to turn into zeros to turn into zeros. So if y'all agree with me, I can do -3 times row 1, right? That doesn't cancel the 3 in R2C1, right? All that does is just multiply with R1C1. Well, I want to actually go ahead and add the product I get here to my row 2. Doing this will give me a new row 2. So let me go ahead. What's going to change, y'all? I get a new what? A new row 2, right? It's the only place I wrote that. So if I'm going to get a new row 2, I can bring down and write my row 1. I can bring down and write my row 3. I am going to wait until I put anything here because I need to perform this operation so that I can put something here. Okay. Now I'm going to come over here to the side to actually show each individual step that's done within this row operation. Okay. So what I have here is that I keep twisting my pen. I don't want to press that button. I'm going to take -3. I'm going to multiply it to row 1. I'm going to add it to row 2. And what my answer is, right, what I get is going to be a new row 2. So this is where I'm talking about seeing patterns, y'all. Okay. I've got 1, 2, 3 rows here, right? So that means that I'm going to multiply, in 3 columns, 4 columns, my bad. Sorry about that. I'm going to multiply -3 by this whole row, right? So the first value is 1, that second value is 2, that third value is a -3, that fourth value is a 5, tells me to add the row 2. Now, obviously, we don't have anything here, right? That's where the answer is going to go. So I'm actually looking right here at 3, 18, -12, 21, right? 3, 18, -12, and 21. This is going to equal a new row 2. So let me go ahead and do that math. Well, if I do 3 times 1, I get 3. Signs are different, so it's negative. A -3 combined with a +3 gives me 0. And remember, I wanted this to be 0. Okay, so that's perfect. That answer goes right here. Then what I do is 3 times 2 is 6. Signs are different, so it's negative. If I add that to 18, what I get, because signs are different as well, negative 6 and 18, I would subtract and get 12. Keep the sign of the larger. That 12 goes here. And then I do 3 times 3 is 9. Signs are the same, so it's positive. Combine that with a negative 12. 3 times 3 is 9. Signs are the same, so it's positive. 9 minus 12. Sorry, I got confused all of a sudden. I should get a negative 3. And so this negative 3 actually goes right here. Okay. Okay, yeah, no, I was looking at that. I'm talking to myself. I didn't think that seemed right. That's why I was doubting myself. Y'all, 3 times 3 is 9. Signs are the same, so it's positive. And then minus 12. Yeah, that's right. Okay. So I get a negative 3. And then if you do 3 times 5, you get 15. Signs are different, so it's negative. A negative 15 plus a 21, you get 6. So my negative 3 goes here. My 6 goes here. Let's go ahead and just kind of finish off what I was trying to make zeros. So at least that way you could see how to turn a whole column into what it needs to be working towards row reduced echelon form, okay? So this is the matrix I'm working on now, not the other ones, okay? I know that I'm not done yet because I'm still trying to turn this into a 0 because it is a negative 2. That tells me that I need to add it with a positive 2 because this is a 1. That's what I'm using to do so. I could take 2 times row 1 plus row 3, which will give me a new row 3. I go and write that here because I know that's where I'm going to do my work. To go ahead and bring down what I can. What's changing? I'm getting a new row 3, which means I can go ahead and write my row 1, and I can go ahead and write my row 2. Looking at my row operation that I'm doing here, I'm going to do 2 times all 4 things in row 1. Then I'm going to add to that what I have for row 3, and then my answer will be my new row 3. So 2 times row 1, it's this. It didn't change. You could look anywhere. Okay. It's 1, 2, negative 3, 5. Plus row 3. There's my row 3. Negative 2. Negative 3. A 4. And a negative 6. These are the values that will equal my new row 3. 2 times 1 is 2. 2 combined with a negative 2, that's 0, which is great because that's what I wanted, right? 2 times 2 is 4. Signs are the same, so it's positive. 4 minus 3 is just 1. And then if I do 2 times 3, I get 6. Signs are different, so it's negative 6. Plus 4, I get a negative 2. 2 times 5 is 10. Signs are the same, so it's positive. 10 minus 6 gives you 4. Those are the values: 0, 1, negative 2, 4. Okay, so we're going to stop here. If a problem said to solve, just going to kind of show y'all, because we will do a problem like it. But if a problem says to solve, what we would want to do, y'all, is we're still working towards this row reduced, right? Your diagonals need to be 1s. This is where I am right now. My diagonal is not 1. This is a 1. Let me do that. This is a 1, sorry. This needs to be a 1. I would notice that this is a 1, and I could interchange my rows. Then after I do that, what I would do is change whatever values are remaining in this column, turn them into zeros. Then I would scoot over here to this column. This needs to be a 1, turn everything else into zeros. So same steps each time. The only thing that changes, of course, is all of this little arithmetic in between the problems. So whenever we come back, I'll probably record it tomorrow. We're going to have a solve a system using row operations. And then we're going to do some 2x3s. We can actually solve those as well. So if y'all have any questions, make sure you let me know. Okay, thanks.